Hello students, welcome to the Turito School Foundation program. Today we would like to discuss about that very important problems for the 9th class students. So for 1D motion, yeah, previous competitive examination problems, just we have to see. Yes, 1D motion previous competitive examination problems which are going to be discussed. So it's very clear we would like to go for that motion in 1D, right. So we would like to go for that relative velocity, yes, we have to take that two objects or which are moving in different direction. So that is the case if the moving objects or car or a bike, they are going to cross over each other and overtake. Just you have to consider the right, VR is equal to V1 plus V2, right. If they are going to be right, this is the case we would like to go for that. So we can discuss that this is going to be V1 and V2, right. They are going to cross each other. Otherwise we would like to go for that VR is equal to V1 minus V2. Yeah, this is going to get that V1 and V2, right. We can go for that relative velocity in some concepts and relative acceleration also we would like to go for that. You have to see that this is the case we would like to discuss that. Two cars, they are going to, yeah, they are all, the two cars are going to cross, yes, they are moving in this direction. Just you have to take, you have to see that they are moving in the opposite direction, just they are crossing each other, right. You have to take that. What is another possibility? One car, it is going to overtake the another one. So they are going to have the direction of motion in the same direction. In this case, the direction of motion is in opposite direction. It is going to move in this direction. Yeah, it's going to move in this direction. Just you have to see. These are going to be identified. Just you have to see that. Right. You have to take that. So if you are having that, you have to take that. That is the case. We would like to go for that. Yeah, you can take that. This is the case we would like to go for that. This is the case. So you have that V1 and V2. Acceleration A1 and, yeah, you have to get that A2. This is A1. You can get just, this is going to be A2, right. If you are going to take the directions, you have to confirm the relative velocity. We would like to go for that. That is going to be UR, let's assume, is equal to, yeah, you have to confirm that is going to be V1 plus V2. Yeah, we would like to go for that. Yes. And relative acceleration also. Relative acceleration also. Yeah, we have to take that relative acceleration, that is very clear. You have to confirm A1 plus A2. AR is equal to, right. So if you are going to look into the term relativity, it's going to be comparable with the another similar quantity from the different frame. just you have to confirm. So if you are going to identify the two velocities which are going to be comparable, then we have to consider the direction of motion also, whether they are going to be in opposite direction, they are going to be in the same direction. We have to take that relative velocity. That's going to be summation. That's going to be the difference. We have to confirm. It's very clear. All right. Let's go for another one. Here we would like to go for that. This is the relative velocity and this is also relative acceleration. They are going to be vector. You have to take that. It's very clear. Now let's go for the problems. You have to take that. In this case, we can describe that the two cars A and B, let's assume they are going to cross each other or overtakes. Yeah, for the present case, they are going to move in opposite direction. They will cross each other. Just you have to confirm at one line of that point. Just they are going to cross each other. You have to solve the problem, right? Yes, you can take that. Two cars are moving towards each other, all right, on a straight road with acceleration of with acceleration on a straight road with acceleration 5 meter per second square and 15 meter per second square. It is very clear. At a certain instant, their separation, you have to get that, their separation is going to be 400 meters, all right. And their velocities are given. That's very clear. Their velocities are 10 meter per second square, 20 meter per second square. How long will it take for the cars to collide? Just you have to take that towards each other. They are going to move towards each other. Yeah, in this case, what they have given, they are going to move towards each other. This is the first car. This is the second car. They are going to move. Yeah, you have to take this one. You would like to go for this one. Yes. Yes, this is going to be A and B. So the separation is going to be, yes, you have to confirm, this is going to be 400 meters. Yeah, you have to take this one. This is very clear. We would like to go for this one. Now, they have given you have to take that. Let us assume first one 10 meter per second. Yeah, this is going to be having 20 meter per second. Let's assume second one, all right. And also they are having that acceleration, that is, you can take that, this is going to be 5 meter per second square, 15 meter per second square. This is very clear. So in this problem, we would like to calculate the time, in how much time does they are going to collide. Just they will meet at one point. You have to confirm. It's very clear. Over the distance of 400 meters they have traveled. Let's assume first car and second car both are going to have that journey. You can confirm. This is very clear. Okay. Once again, we would like to go for the data, what we have, right. We would like to go for that. Yeah, we will use this space. Okay, yeah, right. Given data. Let's assume two speeds are going to be getting that. That is going to be u1 is equal to 10 meter per second. Yeah, u2 is equal to you can take that, that is V1 is equal to 20 meter per second square. we are going to take the two cars, all right. This is going to be A1 is equal to 5 meter per second square, all right. A2 is equal to 15 meter per second square. It's very clear. Now if you are going to get this, right, T, how much time does they will, if the two cars are going to have that total distance, if they are going to meet at one point, they have to cover the distance of 400 meters. Okay, how you can confirm that? They are going to be apart from 400 meters. It's very clear. You would like to go for this one. All right. In what time does they will meet here? You have to take this one at time t seconds. All right. So we would like to go for this one. S is equal to ut plus half a t square. Okay. All right. This is the case we would like to confirm. Okay. Now you can go for, yeah, if you are looking into that matter, these two are going to approach each other, just you have to confirm. First one is going to move in this direction, second one is going to move in this direction. Now you will take the concept of relativity, just that is going to be the relative velocity you have to consider. Consider the relative velocity. So UR is equal to, relative velocity UR is equal to U1 plus V1. So it is going to be identified, that is 10 meter per second plus 20 meter per second. It's very clear, right. Now you have that UR is equal to 30 meter per second. It's very clear. You would like to go for this one. All right. Now you can have the look into that matter of that relative acceleration. Therefore, relative acceleration, you have to take that. Relative acceleration, that is AR is equal to A1 plus A2. So we would like to go for that 5 meter per second square plus 15 meter per second square. So it's very clear, 20 meter per second square. This is very clear. So everyone has to identify that relative velocity and relative acceleration also. Yeah, you have to go for this one. It's better for you. All right. Now, if you are looking into that matter, you can solve the problem easily. Okay, right. Let's go for that. Yeah, you have to take this one. Right. Let us use this space which is having some area. So we would like to go for that. S is equal to, yeah, URT plus 1 by 2 AR T square. This is very clear. We would like to go for that. Okay, all right. Therefore, we are having that 400 U meter, that's going to be UR, that is going to be, UR is this one, that is UR, that is going to be 30 into T plus 1 by 2. What is AR? Just you have to get that 20 into T square. So you will get that cancellation. 400 is equal to 30T plus 10 T square. So you will get that, yeah, if you are going to get the solvation, right. Please you have to get that quadratic equation which is going to be solved, right, by getting that value. Just you have to see that all the values what we have seen, right? Okay, let's go for that. Yeah, yeah, we would like to erase some part, and yeah, we would like to erase some part. It's better for you. Okay. Yes, we can use this space up to this extent. All right. We will use this space. Right. We can go for that calculation. Before going to that, let's have that final equation. That is, you know very well about that, S is equal to URT plus 1 by 2 ART square. Yeah, you have that S, that is going to be the 400 meters, you can take that. So, UR, that's going to be 30 and T plus 1 by 2, what is AR? It's going to be 20 meter per second square. Just you can take that 400 is equal to 30T plus 10T square. You have that. You can take that if you are going to if you are going to get that cancellation, just you have to get that 10T square plus 30T minus 400 is equal to 0. If you are going to make it the simplification, just you can get that, yeah, T square plus 3T minus 40 is equal to 0. Yes, easily you will solve this equation by having that method. Just you have to see that is going to be, you can take that T square, yeah, you have to just you will go for this quadratic expression. You have to solve this problem. Easily you will get the T square plus the 80 minus 5T minus 40, that is equal to 0. Yes, if you are going to get that minus 40 T square, yeah, you will get the T into T plus 8 minus 5 into T plus 8, that is equal to 0. Yeah, you have to get the T minus 5 is equal to 0, that is T is equal to 5. Simply you can solve this problem by getting that from the given equation. Yeah, you have that T is equal to 5 seconds, it's going to be the answer. You have to get this one. It's going to be the correct X value which you can satisfy that equation. So, in 5 seconds it's going to be collide with each other. It's very clear, right? So, basically we would like to go for that. In this type of problems we have to consider the relative velocity, it's very, and the relative acceleration also, in what direction does they will move, yeah. And also we have to consider that equation of motion, this one, right? We can easily solve the problem by getting this one. If you are going to get this one, you can easily find out this. Okay, let's go for another problem, please. Okay, if you are going to look into that, already we have solved that problems. These kind of problems are very, very important. In the last 1 second, it is going to have the journey. It is going to have that some vertical distance covered. That is nothing but height. Yeah, you have to see. Yes, it is allowed to fall down. It's very clear. It has been dropped. Yes, it's very clear. In the last n second, it has been identified, which is traveled in the, this is going to be traveled in the last second, let's assume. Yes. So, the total time which is going to be identified t seconds. Yes, it's going to be t seconds. Yes, right. You can easily find out this. Yeah. So, it is going to be t minus 1 second. All right, it's very clear. Now, we can easily find out that this is the top. Ball is allowed. We can go for that. T minus 1 second. It's going to be h1. It's very clear. h1 is the distance which is going to be vertical distance, that is going to be the height covered by that body in the last second. So, usually you will apply that equation of motion. That is very clear. We can confirm that. Therefore, you know very well about this equation. S is equal to ut plus half at square. It's very clear. So, h in t seconds, you have to get that t seconds distance covered by h is equal to ut plus 1 by 2 g t square. Very clear. If it has been started from that rest position, it is going to have that the ball has been dropped. Okay. From that rest position, if they have given, just you have to take that h is equal to 0 plus 1 by 2 g t square. All right. So, you will get that h is equal to 1 by 2 g t square. This is the one equation we are having. All right. This is very clear. You can go for that. Now, you can apply that same equation for that equation of motion. Yeah. Yes. In t minus 1 second, just we have to take that. In the last second, it's going to be getting that distance. You have to confirm. Let's assume. So, h1 is equal to ut minus 1 plus 1 by 2 g into t minus 1 whole square. Yeah, h1 is equal to 0 plus 1 by 2 g t minus 1 whole square, right? Yeah, you have to confirm that this is going to be the you have to confirm this one. These two equations are going to be very important. Let's have the look into that matter. All of you please have the look. We are going to get this one, right? We would like to go for that in the last second, it has been covered the distance. Okay, you have to get that. You have to take this one h1 and h2, just you have to write. Okay. Okay, just you can go for that. This is very clear. You would like to go for h minus h1 is equal to, that represent the distance which is going to be travelled in the last 1 second. that represent the distance traveled in the last second. Let's get okay. Now you will go for that. Sometimes they are going to ask the problems which are going to be related to these kind of case studies. You can accept that problem and you have to look into that matter. If they have given that in the last second before reaching the ground it has been traveled that 40 meters or 50 meters, then estimate that. If you know that time, in this equation, if you know the time taken just or the distance covered, if you know this one S, okay, and that time also, easily you will solve the problem, right? Okay, it is very clear. If you know H1, then you can calculate H. Sometimes they have given that H1, you can able to solve the problem for H, easily you can solve that. Let's have that one problem based on this model. If you know that time taken to cover the distance of H1, at the same time you can get that solvation, that is for total height. Okay, let's have that looked at. It's very clear. So you have the two set of equations for this one. What we are having, that is going to be H is equal to 1 by 2 gt square. It's very clear. This is equation number 1. So in the last second it has been traveled that 40 meters. Therefore H by H minus 40, that is going to be 1 by 2 into g into t minus 1 whole square. It's very clear. This is equation number 2. We are going to get that by solving this equation. Minus 45 is equal to, that is going to be, we will get this equation, you will get is equal to, that is you can solve this problem, minus 5 you will get that minus g t. So minus 45 is equal to minus 10t, t is equal to 4.5 seconds. Very clear. If you are going to know that g is equal to 10 meter per second square, it's very clear. After getting that, you can calculate that height. Therefore, your aim is to calculate that h is equal to 1 by 2 into 10 into, that is going to be 4.5 whole square. You will get that 5 into 4.5 into 4.5. Just you have to solve this problem. Easily you will get that. If you are going to get that, you will get that. You have to solve this problem, 22.5 into 4.5. So you will get that, you will get the, you will get that 101.25. So h is the 101.25 meter. Easily you will get that. In this way we will solve the problems. Okay. Okay, students, have a nice day. Let's have that another session. We would like to go for discuss the more problems based on this 1D motion, which is going to be covered that vertical distance in different time intervals. Thank you very much. Have a nice day.